So today is day 5 out of 5 for our scientific method lesson, and today we'll be learning how to use the scientific method in real life situations. What is scientific literacy? It involves applying critical thinking skills to everyday life, particularly to claims related to health, technology, and advertising. Why do we need to be scientifically literate? Are all of us going to grow up to be scientific researchers? No, but we must develop inquiry skills that will allow us to make informed decisions about things we encounter in everyday life. Here's an example. Let's suppose you see a commercial for a weight loss pill that claims you would lose weight if you use it. Before rushing out to buy this product, what are some things you should think about? You may think of the following. How many people were tested? What is in the product? How long do you have to use it to get results? And what are some of the side effects? All these questions will up the validity of the product. Where can you go find the answers to these questions? You can find them at State Consumer Product Information Agency, friends or relatives who have used the product, company webpage, or scientific journals containing information about the pill. This kind of thinking is called inquiry skills. Inquiry involves making judgments about the reliability of the source and the relevance of information. Inquiry means to ask questions. Reliability meaning, can we trust the information? Relevance is the information important to the matter under consideration. More questions to think about. Where did the information come from? Who did the experimental research? How was the experiment done? Did the people who conducted the study have a selfish motive in obtaining positive results? How do you know whether or not you can trust the information from a research study? An experiment should be able to be repeated with identical results. How do you know whether or not you can trust the information from a research study? Good experiments are peer-reviewed. Peer review is when several scientists examine the details of an experiment. What is a hypothesis? Tentative answer based on observation, which can be supported or refuted through experimentation. It can be disproven but not proven to be true. What is a theory? Theory of evolution, theory of energy and mass. A theory is an explanation supported by observations and experiments that can be used to explain related occurrences. Theories are valid as long as no evidence disputes it, therefore can be disproved. A hypothesis that is accepted as a good explanation. What is a scientific law? Newton's law of gravity. In addition to theories, scientists also recognize certain facts of nature called laws that are agreeably known to be true but don't explain why, like a hypothesis. Laws have a higher degree of certainty than theories. Proof, truth, or fact. No real proof or absolute truth in science. Fact, which are indisputable observations, are as close as we get. Arrive at a logical conclusion based on evidence. Proof in science, not something that implies it can never be wrong. Conclusion. Keep in mind that all scientific explanations are subject to change as more is learned. With new information, scientists must be willing to change their thinking and therefore their explanations. What is the main cause for a stomach ulcer? Bacteria. And that's all for today.